Turn back this direction. And I'm going to call on groups randomly for the steps they tried to do. Doesn't mean you got it perfectly, but the steps you tried to do from notes, okay? So, real quick, pick a spokesperson from each group. Who's going to talk? You just have to tell me what step you were trying to do, okay? All right, here we go. Group number 5. What's the very first thing that you thought to do? Yeah, what's the correct term for taking a 3 out, everybody? Factoring. So, good. Kathleen, we take the 3 out. What was left? Good. Don't fill in the blank. So you took the 3 only away from these 2 terms? What'd you do with him? Good. Why does there need to be 2? To balance it. We're trying to keep everything balanced. Who's in chem or is taking chem at some point in time? Is it important to keep your equations balanced? Ah, so we have to do that in math too. Okay, so blank and blank in a good way, like we're supposed to fill it in. Oh, look at you trying to help out a future group. I wasn't going to talk about that yet, but you're totally right. Why is Kathleen saying to put a 3 times over here? This blank is, yeah, do you see it, Sam? This blank has a 3 on the outside, right? So if I'm trying to offset and keep it balanced, if I have a 3 blank here, I need to offset by a negative 3 blank here. Does that make sense? Look at you. Nice. I like it. Group number 3. What should you try to do next? That's okay. That's okay. So look in your notes. What's after step number 1, getting a leading coefficient of 2? What did you need to do, Wyatt?
Add extra?
I think it's the one right above that.
Leading coefficient of 1.
Oh, then read the second one.
Okay, 1 for the square.
Yes. By what?
Adding by 0.
Adding by 0 creatively. Who can help out as to what we're supposed to add in this blank? Where do we get it from? Group number 4. Now that's kind of hard, right? 10 over 3 over 2. Is there an easier way? Because that's a complex fraction. Tony, did you have another way of doing it besides dividing by 2? Yeah, multiply by 1/2. Isn't that a lot easier to your brains? But Tony, help me out real quick. Jason, hurry up. You've missed a lot of class. Talk to me after. If we have 10/3 and we're trying to cut it in half, we can say times a half. But Tony, that's not enough, right? Divide this by 2 and what? And square it. Good. So then when we divide it by 2, guys, we can simplify this before squaring, right? Does anybody see, wouldn't it be 5 over 3 squared, right? 5 over 3 squared. Can we do this mental math, honors pre-calc kids? 25/9? Yeah. Double check, but it's good. So 10/3 cut in half. We're in the back of our homework spirals, Jason doing a bell work, an opener. 10/3 cut it in half and then square it, 25/9. Wait a minute, hold on. Kathleen, help. What am I supposed to be doing with the 25/9? Yeah, exactly, Robbie, you're right. You're totally correct. 25/9, right? Now, do we like these numbers? Let's be honest. No. But are they right? Yes. Sweet, let's keep going then. Okay, so we have the y equals. So Wyatt helped us out reminding the steps. Number 1, get a leading coefficient of 1, which is what Kathleen was doing by factoring out the 3. Number 2 is add by 0 creatively to form a perfect square. What's step number 3? Group number 2. What are we supposed to do next? Robbie, you're in your notes. What was the next step? Leading coefficient of 1. Form a perfect square. What's step number 3? Under completing the square. Factor and simplify. What are we supposed to be factoring? Our perfect square, right? Real quick reminder, vertex form, y equals, we have an a out in front, possibly x minus h quantity squared plus k. True? Hold on, let me move that. Gavin, can you see? I'm sorry. That's what we want. Well, we have a trinomial. Can't we just factor them down? Yeah. So group number 6. How can we factor? Or what happens when we do factor? What's inside? But we're getting there now. But you guys didn't get there in your groups? It's okay, Sam. What do you think the first term is going to be? Helping out. Thanks, Jason. Is it okay if we pass it on to Jason? Okay, what do you think? X? Why minus? Because you're thinking of it right now. What in your brain told you minus? You're totally right. Good. The two inside terms have to add up to a negative. The only way in a perfect square for that to possibly happen is if the inside term is negative. Good job. Did you figure out the number? Yes. How'd you figure that out? There are two ways of doing it. If perfect squares every time, oh, where's my nice black marker? If perfect squares every time, let's do x minus h times x minus h. Okay, the perfect square from the standard form equation. Kim, can you see me okay over here? Okay. If we are trying to, square it, which we're going to FOIL, not kill a puppy, we end up with x squared minus 2hx plus h squared. If we're trying to get back to who is h, there are two ways to do it, and Sam actually did it a totally different way than my brain would have. He looked at the middle term and he said, okay, 10/3, I need half of that, because whatever term you're looking at is double the original h as far as coefficients. So his brain said, take half of the coefficient, which would be 5/3. My brain would look here and would say square root that, and that's h. Either way, your brain can get to the h. Either you have to think of cutting that middle coefficient in half or square rooting that coefficient. So what's 10/3 cut in half? 5/3. And technically, what's negative 10/3 cut in half? Negative 5/3. And what's the square root of 25/9? 5/3. Either way, you get there. Now, what's the last thing that we have to do? Who's still chilling? All right. So why am I going to go ahead and write it like this? Why did I change the 7? Why is it easier? Yeah, common denominators. Can't we say 7 times 9 is 63, so then 63 over 9 is 7? And can't we do 3 over 1 times 25 over 9 is 75/9? I'm trying to help you guys with mental math, because if you're getting in higher math, the faster your simple facts can go, the better it's going to be for you. And especially, remember Calc Chat? They don't always show all their steps. They're using mental math. I mean, they're like college grad students, but either way, we're trying to get you better and better in your math skills, including the basics. So what do you guys get when you do 63 minus 75? Can't you guys do 2-column subtraction in your heads? It's not too bad, isn't it? Just 12? Is there another way of doing that? Couldn't you say that there's 7 to get to 70, and then 5 after that, and 7 and 5 is 12? Either way, you get minus 12/9. Can that reduce it all? Yeah. So at the end of the day, do we now have our standard form, even though it was gross? Yes, and what does that standard form tell us? What's our h, what's our k? 5/3. Ooh, is it negative or positive? Look at your form. X minus h. Come on, we've done this with circles. Positive 5/3. What's our k? Negative. Because you would have to add a negative to get minus 4/3, and you'd have to subtract a positive to get minus 5/3. Now, hold on. Did anybody actually do the cheater formulas to see if they could find the vertex another way? Did anybody find the cheater formulas I was even referring to? Robbie, I'm coming back to you. Hold on. Anybody find the cheater formulas? We wrote them down twice yesterday. Nowhere? H equals. Gavin, what'd you got? I'm going to be honest with you. That's not the only way to get down to standard form in the vertex. You can use that cool little cheater formula that you saw yesterday and might have seen in Algebra 1. Why is it so nice? Who's B? Negative 10. So wouldn't I plug in a negative 10? Who's A? 3. So 10 over 6? 5 over 3? Oh my goodness, and I didn't have to complete anything. Couldn't you take that and go plug it in standard form and be like, haha, wait, where would this number come from? A, yeah. So x minus h, you could find h over here, but what's the dilemma? Maybe you didn't even realize it, but I mentioned it yesterday. We still have to find k. So we have to go plug him in, function notation, to f of x, right? So plugging him in. Is this going to be fun? I don't know. We'll find out. Yeah, exactly. So let's take our f of x. Now we're going to plug in 5/3. So we need 3 times 5/3 squared minus 10 times 5/3, just reminding you of function notation, right? The real question, are you more scared of this or this? This leads you right down to the answer. Pull it out, you're done. This, you better not make any mistakes. Either way, you're struggling with fractions. You just choose which way you want to go. Does that make sense? So at the end of the day, if I was to go ahead and not be scared of my fractions, tackle it head on. Why am I going to make this? I'll just do 7 for right now. I'd have 75/9. Pause. Can anybody figure out why I'm about to do 150/9? How'd I get that if 10 times 5 is 50? Yeah, common denominators. I'm trying to save my brain as much as possible. I still have some more calculus classes today, right? So I multiply by 3/3. So 10 times 5 is 50, times 3 is 150. Got it. And then I'm going to go ahead and make... Fractions aren't that scary if you make them nice for yourselves. What's 75 minus 150? Negative 75. Negative 75 plus 63? Negative 12/9, which is the same thing as negative 4. You choose. You choose. But does either one take work? All right. So you got to figure out which one's better for your brain and then become a master at it. Does that make sense? Cool. Let's keep going. In our notes. Now, as you guys write down this page, I have a little worksheet, because remember I said there's book work due tomorrow and, and a worksheet that I'm adding in today. The worksheet might be due on, I might give a little bit of grace on the worksheet, except we're moving on to 2-2 tomorrow. So you might not want to bank on not starting him at all today. That'd be a bit of a struggle. He's going to be due on Monday, but we're not going to take much time tomorrow on him. We're going to go over 2.1 questions like normal. And even though the worksheet isn't due entirely tomorrow, you might want to start on it. So let me pass that out as you guys write down the following page. Oh, I'm sorry, it's on the ceiling. One of these days my projector will get put in the right position. Is that better? Yeah? Okay. Go for it. Kim, I think it ended up working, right? If you solve for the 0 for yours for H. Did it end up working? That's what you had, huh? Maybe you can drop by after school so I can see how you're doing it. Because you're right that it worked yesterday. The only problem is now, see, it's not going to work so well. But 10 over 6, 5/3 would be the H. Huh. Yeah, drop by during lunch or after school. Let me peek at what you're doing. Just not following along really quickly right now. When you get the worksheet, name, period, group number. guys close? Yeah, Robbie, what's up? Is it that bad? Hang in there, it's going to turn off soon. Okay. Do you guys see the whole concave up like a cup and concave down like a frown? Yeah? Do you see what's making it concave up like a cup and concave up down like a frown? Aren't they saying the leading coefficient is positive? And who's the leading coefficient for a quadratic? A. Good. So if A is positive, man, I just blocked it out. If A is positive, concave up like a cup. I give up. If A is negative, concave down like a frown. But we talked about that earlier this year, right? I think so. Did we already talk about how vertices can be, ooh, plural of vertex. Vertices can be either positive or negative? No, that's not right. Leading coefficient can be either positive or negative. Vertices can be either, if the vertex is the lowest point, which one is it? Yeah. So here's a case where I have a minimum. Here's a case where I have a maximum. But here's a tricky thing, and you might not even realize it until you actually get into problems and try solving for them yourselves. It's going to be a little counterintuitive that the A is positive, yet the vertex is a min. If you think about the picture, oh, it makes everything so much easier. If it's concave up like a cup, an upwards facing parabola, you're going to have a minimum as a vertex. If you visualize the graph itself, it makes everything easier. But it can be a little counterintuitive that a positive A makes a min and a negative A makes a max. But we'll face that if it comes and if you guys check on it. What did we already talk about with the vertex? Oh, he's HK, right? A is less than 0, concave down. CD for concave down, CU for concave up. Quick abbreviations we use in calculus a lot. But I want you guys to check out the axis of symmetry. We haven't really talked about him this year. Not much, anyway. Axis of symmetry. What does he always go through? The vertex. And if he always goes through the vertex for a up-down, a vertically oriented parabola, aren't all vertical lines, wait, help me out, vertical lines, we've reviewed this. What equation will vertical lines have? What type of equation? X equals. Good, 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 good. So if the axis of symmetry always goes through the vertex, and if the equations of these are always X equals, guys, what X does this go through? H. Nicely done. So really the axis of symmetry is just X equals H, which we could find from completing the square, or we could find from our cheater negative B over 2A. Either way. Either way. The axis of symmetry will always be for a vertically oriented parabola, which is the only type that's a function. The other one fails. The vertical line test. X equals H, aka negative B over 2A. Abbreviations for, guys, help out. What's CD? Concave down. Remember the concavity, the curvature of the parabola? So then what's CU, everybody? Help out real fast. Concave up. Good. Concave down like a frown, concave up like a cup. So I want you guys to check out your worksheet. And let me get the light back on because some of you are starting to get tired. Is that right? Nope, that one. Okay, looking at your worksheet. Some of you have already started, and that's awesome. What do you see the first section of problems looking like? It is asking for axis of symmetry, which we just talked about how to find that. What else is it asking for? The zeros, the vertex. And doesn't it also have a graph that it wants you guys to put the parabola on? Let me see if I can get, is this the first one? 3x squared? No. Where's this guy? Oh. This is an example. Let's do this in our notes. It's not a specific one, unless you guys can find it on the worksheet. I think I might have been tricky since you're honors and made you a whole brand new one for us to do in our notes. Can anybody find this on the worksheet? Is it there? Yeah, I don't think it is either. It's a lot like numbers 4 and 5. Why is this one even harder than where the worksheet starts? What form is numbers 1, 2, and 3 already in? It's already in standard form. So when it asks for vertex for number 1, hey, I'm helping out with the first problem. When it asks for vertex of number 1, what are you going to be able to take right out of the form, right out of the equation? Which one? Careful, x minus h. Negative 1, comma 4. Yeah, so for number 1, the vertex is negative 1, 4. What's the axis of symmetry then if x equals h is the formula? Yeah, you can just steal negative 1. How would you find the zeros for number 1? Make y 0. Yeah, it's just an x-intercept, right? Make y equal to 0. And what are you going to have to remember when you eventually have to square root a squared? Look at number 1. If you set y equal to 0, go ahead and do that. 0 equals, make y equal to 0. Aren't you going to have to subtract the 4, divide by a negative 1? What happens when you square root a squared? Plus or minus because absolute value. Remember we talked about why it's a plus or minus? Something that gets lost a little bit in earlier maths. You've probably seen it, you just forget it. But we have to do a plus or minus, which is how you'll get 2 zeros if they exist. And how could you graph the parabola from all the information that you find? How many points comprise a parabola? How many points do you need to make a parabola? Oh, you don't know this one? How many points do you need to make a line? Just 2. How many points to make a parabola? 3. Because a parabola is missing an A and a B and a C. So you would need 3 points to solve it, like with substitution, elimination, all that jazz. For lines, we only need 2 because of mx and b. Anyway, but why is numbers 4 and 5 harder, like the example that we're about to do? What is it not in? Yeah, thanks, Johan. It's not in standard form. So what's the vertex? Could you plug into HK using our cheater formula? Sure. But instead of plugging in straight in using our cheater formula, let's practice complete the square since we started it today. So kiddos, what's the first step of complete the square? In your notes, pause on the worksheet. I want to see worksheets behind the notes. Pause, 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 pause. Back in our notes. Back in our notes. Let's do this example all together, which is like numbers 4 and 5. So if you want, you might want to go ahead and put like numbers 4 and 5, which are harder than 1, 2, and 3. Maybe this guy won't be too bad. Help me out with steps. What's the very first thing that we should do? Good. Factor out the 3, which is the same thing as the step that our notes get a leading coefficient of 1. But Robbie, do you remember who you factor the 3 away from? Is it everybody? Good. Just the x term. So the x squared term, the x term, the little 12 goes out here. What's going to go here? That's what Kathleen was telling us at the beginning of class. What goes here? You guys are all making it too hard. What I meant was leave a blank. I think you all were trying to solve for it. Sorry for making it, yeah, Tony, is that what you were thinking? I just meant leave a blank. But if we leave a blank there, you got to minus a blank here. And why am I going to do what Kathleen did and do it 3 times? Because I factored out a 3. Now, 60 seconds. Get ahead of me. Can you finish this whole problem off and get the vertex yourself? This one's not a nasty fraction one. We'll get back to it in 1 second. We'll get back to it in 1 second, Jason. Anybody else put your worksheet away or I'm going to come steal it? Finish this example first. Finish this example first. Because the wording in the answers are very important. Is this the exact same problem in class? It's super close, huh? Guess I wasn't very creative, sorry. Leading coefficient of 1. Getting the middle term. Using the middle term, I should say, to fill in the blank. Factoring. Simplifying. I'm going to start playing because it shouldn't take you too long. Did you guys get 9/4 in the first blank? Sweet. Did you get 18/4 in the other blank? Oh, I did it twice. That's right. Sorry. Kathleen's having me do it a different way, which I think is a really good way. Minus. Why'd you all look up? Because it was supposed to be 9/4, right? Because the 3 is already chilling. But what happens when you multiply 3 times 9/4? 27/4. I can't even multiply today. What'd you guys make the 12? I would do 48/4. Wouldn't that make it easier? I think. But don't we also have to factor? So we have our 27/4, we have our 48/4. When you guys factored, the 3 should have been in front. And you got x minus 3/2, right? Quantity squared. Which should then go ahead and give us, as our final standard form, x minus 3/2 squared plus, what'd you guys get, 48 minus 27? What was it? 21, good. So what's our vertex? Not negative, x minus h. I know it's hard. X minus h, positive 3/2, and then plus k, 21/4. This is for numbers 4 and 5. What are you going to answer as far as a maximum or a minimum? Oh, it's not a max. See, I told you it's counterintuitive. What kind of parabola is this? Think about the picture. It's concave up like a cup. And that positive a, concave up, makes what kind of vertex? Minimum. But see, I heard at least 3 people say max when I asked. Why? Because it's a positive a. Your brains just jump to max without thinking it out or thinking it through. It's a min. Axis of symmetry, what do we get to do? X equals steal what? Steal the h, steal the 3/2, which would have come from negative b over 2a. And then let's practice that math I was talking about a second ago. How do we find the zeros? Either set the original equal to 0, and have to think through factoring with the x method using 36 and negative 9, or set the completed the square equal to 0. Or quadratic formula. If you do the completed the square, because some of you might see factor out of 3, life is a lot easier. But if you do completing the square, if we were to go ahead and subtract the 21/4, divide by 3, which will be times 1/3, plus or minus square root. Does anyone see a problem as to why I shouldn't even bother factoring or using the quadratic formula? What's true about a square root of a negative? This parabola is not going to touch the x-axis. It doesn't have any intercepts because it's been translated up. Zeros, this guy has none. But if it did have, right? If it did have zeros, would I have been able to find them by doing a plus or minus square root of both sides and adding the 3/2? Yes, I would have found it. But guess what? Some of you were thinking, wait, I can totally make this work. But if we factor out a 3, x squared minus 3x plus 4, 2 and 2 doesn't work. 1 and 4, oh, that could work. But only if a positive and a negative should have made that a minus. Some of you would have tried the quadratic formula. You would have gotten square root of a negative as well, which wouldn't work. Question, Austin. Yeah. Oh, what I did is I thought of it 2 ways. Once I have it written out, like the whole x squared minus something x plus something, you can either take this coefficient, cut it in half, and go straight to the h for what you're going to write as your perfect square, or take the square root of that. So where the nice thing is where you can always look for h is right here where you've cut this guy in half. It'll always be the same. Does that make sense? But if worst comes to worst, you can always square root this guy and steal the middle guy's sign. So either way. Is that cool? Do you understand the idea? Cool. Let's see if we've missed anything from notes. I think that we could take a problem like this from homework, like not the worksheet, but homework, and find a vertex and find an axis of symmetry. You think we could do that? I think so. I think we've practiced that a lot today. And then we're done with the book work. So let's look at the worksheet really quickly. Is there anything else confusing on the worksheet as you look front and back? 1, 2, and 3, already standard form. 4, 5, 6, and 7, not standard form. Pause. Can you guys go down to the second section of the worksheet, 4, 5, 6, and 7? And can you read that little note that I wrote off to the side? Do you see it? It's like a little handwritten note. I said by completing the square and doing vertex form, but can I have you guys write, right underneath that handwritten note, can you write h equals negative b over 2a? Because on some of these, you might choose h equals negative b over 2a as the easier way. And as long as you can get standard form for me using that formula, I won't totally mind. Okay? I think completing the square is the easier way. It ends you right at the answer, but the answer pops out at the end. The other way, oh, so many math mistakes can occur, but you're doing the same math either way with fractions, common denominators, squaring, etc. But where does it get weird? How about Roman numeral 3, the application section? Everybody turn to the back of your worksheet. Turn to the back of your worksheet. Applications. Ugh. Look at numbers 8 and 9, which is very different from 10 and 11. 8 and 9, what do you see? Fractions, yeah, a nasty quadratic, right? Both of them have nasty quadratics with fractions that are meant or made to show something. One of them is talking about a ball being thrown. One of them is talking about the path of a diver, like diving off of a diving board. But can you guys keep looking through the problem and find what they're actually asking for? Max. How do we find a max? We could graph, but aren't we trying to figure out how to deal with quadratics by hand? That's what this whole lesson's about. How can we not use our graphing calculator? Vertex. How do we find the vertex of both of these guys? Ugh, complete the square? Maybe. What's your other option? H equals negative b all over 2a. But can you find the maximum, the vertex of those two? I think so. It's just going to take a little bit more work than maybe the other ones because of the fractions. But we dealt with fractions today, and you guys made it. You're still breathing, right? Check your pulse. You still there? I think so. Okay, numbers 10 and 11, though. What's going on there? A lot of words. What do you see up here on the board? Let's do number 10 together. We have 5 minutes left of class. Everybody, back to your worksheet number 10. Back to your worksheet number 10. Take a second. I want you to read the whole thing and figure out why it's harder. Some of you can tell right away. There's no equation. Okay, read the whole thing. Read number 10. Take a moment. Read it to yourself. Have you started drawing a picture and labeling it with things like X and Y? That'd be a good idea. Draw a picture. Label dimensions of that picture with X's and Y. And I want you to circle the most important words in the problem. I want you to circle the most important words in the problem. Draw a picture. Label with X and Y the dimensions of that picture. And I want you to circle the most important words in the problem. Would you guys make X and Y? Is X the length or the width? Which one? Width? Is that like that? Does that look good? Cool. What's something that you circled? as an important word in the problem. There's multiple. 500 foot fencing, good. What else? Oh, come on, there are more important words. Which one? Okay, what are the dimensions? That's true. You're supposed to be finding dimensions. Vico, what'd you say? Largest, yeah. Largest yard. Largest area. There's one more word that I think is important, but we already did it, right? We made it a rectangle. The only thing I see, the most important ones, I think are those two. Because one of them has to do with perimeter, and one of them has to do with area. And both perimeter and area, we have review formulas from geometry, right? With perimeter of a rectangle. Yeah, we can do that. An area of a rectangle. Pause. Do you agree with the picture at hand? Perimeter, add up all the sides. 2x plus 2y equals the perimeter. And then area, multiply length times width, base times height, or x times y. Is there anything I can plug in to either of these formulas from that problem? What's the 500, Tony? How did he know that? The 500 is the perimeter. The fencing goes around the, have you guys ever heard around the perimeter of, right? Or if like the security guard is trying to like scope out a place or trying to make sure everything's safe, they go around the perimeter, right? Around the perimeter. Cops kind of use that too in a sense. The perimeter, it's there around, it's the outside. Fencing goes around or outside. So yeah, it's awesome. I can say 2x plus 2y is equal to 500. We've seen something like this year. We have too many variables down here. Can we use this? Can we use the Blue's Clue? It's a little bit more complicated than the ones that went in the handy-dandy notebook, but can we use this clue to help us plug into this equation, to help us find the max? What happens if we solve for y? 500 minus 2x all over 2. Isn't that the same thing as 250 minus, ooh, that's not going to help. There we go. Isn't that the same thing as y equals 250 minus x? I did not kill a kitten. Totally legal, because what did I do? I factored out a 2 and then I was able to reduce. So what can I do down here in my area formula? Isn't this the same thing as 250x minus x? Oh, it's a quadratic! Why is it on this worksheet? What's section 2.1 all about? Quadratics. So how on earth should I be able to find the max? I don't know. Do you guys want to do negative b over 2a, or do you want to complete the square? Either way will work. Perfect timing. Go team. What's due tomorrow? Bookwork, 7 a.m. You can ask me, though, a question or worksheet if you've already been able to play with it, but the worksheet itself will not be due until Monday. Sound good? Get out of here, cool kids. Good job on the quadratics. I'll see you later. Alligators after a while, crocodiles.